So part B example problem for binomial distribution. Problem 1. Out of 800 families with 4 children each, how many families would be expected to have? First subdivision is 2 boys and 2 girls. Second subdivision at least 1 boy. Third at most 2 girls. And fourth subdivision is children of both sexes assume equal probabilities. Actually, this problem contains the data 800 families. So let us consider that 800 as capital N and keep that 800 separately, because the remaining portion only we can compare with the binomial distribution, and the 800 is only used to calculate the total number of families. So after finding the probability, we have to multiply by 800 at each case. Now we are going to compare the given problem with binomial distribution. Here childbirth is the random experiment. Even though the outcomes by child or girl child are known, we cannot assure the accurate result at each trial. Each childbirth is taken as a trial, and this probability values never change, we know, because they already given equal probabilities. So repeatedly for 4 n trial means here 4 trial, 4 children. So this is binomial distribution, and let us assume birth of a boy as success. It may be even taken as girl as success, because we are taking this as boy because the count given is 2 boys and 2 girls. The first boy assumption is taken. Therefore, we are taking childbirth of a boy as success. Here P 1 by 2 and Q 1 by 2. Now consider this picture. We are talking about 4 children families. So that family will definitely have children of the case among one of this. Either all 4 children as girls, or all the 4 children may be boys, or 1 by 3 girls, 2 boys, 2 girls, and 3 boys, 1 girl. So totally chances are only this 5 cases. Now consider the first case, all girls. Here we are talking about x random variable as number of boys. Therefore here number of boys is 0, and this probability 4 is 0, 1 by 2 power 0, 1 by 2 power 4 is nothing but probability of x equal to 0. 0 by uh, case as the probability value. In this picture 1 by and 3 girls. This count has uh, equivalent probability value as 4c1 1 by 2 power n 1 by 2 power 3, that is symbolically p of x equal to 1. Similarly 2 boys 2 girls case 4c2 1 by 2 power 2 1 by 2 power 2, this is p of x equal to 2, that is number of boys is 2. And the next one is 3 boys and 1 girls, which is obviously 4c3 1 by 2 power 3 1 by 2 power 1, this is p of x equal to 3. These probability values are evaluated in the four cases. When we solve all the 4 cases, this probability values will be useful. Now all the 4 boys case 4c4, it is 1 by 2 power 4 1 by 2 power 0. This is p of x equal to 4 case, that is all the children, 4 children are boy children. Now let us consider this 4c0 4c4. From 4c0 to 4c4 calculation of these values, we know 4c4 4c0 and 4c4 are 1, then 4c1 and 4c3 are equal, it is 4. 4c2 is calculated as 6. All the values are going to be used in the derivation, that is evaluation calculation steps. Now in this table, just for extra clarity, we are listing out all those probability values and evaluating. We get the following values. Here the respective number of families, but there is no need to do this table and all. Just for a clear cut idea, we are taking this each probability case calculation here. They are actually explained in this step. Now consider the first subdivision. X already we know the number of boys sexes. And first subdivision is probability of two boys and two girls case. That is exactly we are going to find the probability of uh, two boys and two girls. Two boys and two girls means actually x is denoted as number of boys, therefore x is equal to 2 is the equivalent. There is no need to represent girls. Obviously 2 boys means remaining 2 will be girls. Now this picture, this 2 boys and 2 girls is uh, having one green tick mark. This is the only case relevant to subdivision 1. Now we are going to calculate that p of x is equal to 2 means 4c2, that is ncr p power r q power n minus r. Calculating the value we get 3 by 8. Now the number of families having 2 boys and 2 girls is calculated by just multiplying this probability value with 800, which is 100. 100 families may have two boys and two girls. Now second subdivision is probability of at least one boy. We should know the meaning of at least one boy. The those families with minimum number of boy is 1. It may reach maximum number 4 boys. So in this picture, 1 by case minimum number is 1 means 1 by case is uh, with the green tick mark. 2 by also taken, 3 boys and 4 boys. All these 4 cases are under the at least 1 by case, except 4 girls. You can take all those. Again see the same thing, at least 1 by we can represent it as probability of x greater than or equal to 1. It means starting from 1 by that family can have at most 4 bytes. So all the chances p of x equal to 1, 2, 3, and 4 cases are added. Instead of doing that 4 calculation part, we can take the complementary, that is nil 0 by case, and subtracting it from 1 we get the value which is 15 by 16. So 1 minus of p of x equal to 0 is enough, because at least one opposite meaning complement portion is no by 0 byte. So answer is 15 by 16. Final step is to find the total number of families. Multiplying by 800 we get 750 as the answer. Third subdivision is probability of at most two girls. It means the maximum number of girls in the family should be 2. So the lowest value may be 0 girl or 1 girl or 2 girls. It should not cross 2 girls. 3 and 4 girls cases will not come under this. Now the picture, 2 girls case, then 1 girl and 0 girl, because at most 2 girls. So all the cases 0 girl, 1 girl and 2 girls are going to be added, but we are actually having the random variable as boys. Number of boys only x denotes, so it's each of the girl case will be converted as boys. So 0 girl means 4 boys, so the equivalent probability of 4 boys case, plus 1 girl, probability of 1 girl means probability of 3 boys, because 4 children, out of 4 children 1 is girl. So the obviously the remaining 3 will be boys. Similarly, probability of 2 girls means 4 among 4 2 are girls. So automatically remaining 2 are boys. So the above step, 0 girl, 1 girl and 2 girls are uh, equal to the respective boy case, 4 boys, 3 boys and 2 boys. Evaluating 3, we can easily do 0 case and 1 case and subtract it from 1 as usual. So the final answer is 11 by 16. To find the number of families, we are going to multiply this probability value with 800. Answer is 550. That is 550 families may have the chance to having at most 2 girls. Now the fourth subdivision, children of both sexes. So two genders, both the genders should be in this fourth subdivision. For that we are taking both boy child as well as girl child cases are having tick mark here, except all one single gender, that is all boys all girls cases are omitted actually. But by calculation we know children of both gender, we can take the complementary portion, probability of children of same sex, that is 1 minus of probability of all boys plus probability of all girls. So evaluating, we get 7 by 8 as the answer. For finding number of families, we as usual multiply with 800. So the answer is 700 families. 700 families have the possibility for having children of both the genders. Now, giving basic steps and explanations only needs more time. Actually, if we correctly apply the binomial distribution concept to the data, we can easily solve this problem within 10 minutes and score full marks. And one more point, in the pictorial representations, the count of the children for both the genders are given 1 by 3 girls, or 3 boys, 1 girl, or 4 girls. That means the count only we are representing, not the posture of first. If the first child in the picture is boy, it does not mean the first child. Actually, all the pictures are just to represent the counts. One boy child in the family means that family may have first child as boy child, or second child as boy child, or third or fourth single boy and remaining three girls. We just represent in the picture as the count 1 boy and 3 girls, or 1 girl and 3 boys. We don't know uh, which child is by child. That's why we are using the 4C0, 4C1, 4C2, etc. in the calculation of probability values. Here we are taking or assigning boy child birth as the success, but in a similar pattern we can take X as the girl child, that is success case, random variable as girl child birth, and the procedure can be uh, expanded as usual, but the numbers should be properly placed. Girl or boy should be represented in a correct way. We'll get the same answers for all the subdivisions.